Imagine standing on a prehistoric beach with one simple problem. The food, fresh water, or suspiciously attractive island you want is on the other side. We have no sail, no rope from a hardware store, no weather app warning you that paddling into a storm is a terrible lifestyle choice. What you do have is wood, stone tools, plant fibers, and the extremely human belief that maybe this floating thing will not kill you. So how did ancient humans build the first boat? The obvious answer is they hollowed out a log. And yes, the oldest surviving boat we know is a dugout canoe from Pesse in the Netherlands, made roughly 10,000 years ago. But that answer immediately breaks. Humans were crossing open water tens of thousands of years earlier. The boats that carried them are gone. Wood rots. Reeds vanish. Bark disappears. Archaeology is left staring at islands where people somehow arrived and asking an awkward question. What were they riding? To answer it, we need a preserved canoe, stone woodworking tools, volcanic glass from an island, dangerous ocean currents, and modern researchers willing to rebuild Stone Age boats and paddle them into the sea. Because the first boat may have disappeared, but the problem it solved left evidence everywhere. The short answer is that the first boats were probably built from whatever already wanted to float. A fallen log is buoyant without asking permission. Reeds can be bundled together, branches can be lashed into a platform, bark can form a light shell, and with good enough stone woodworking tools, a large tree trunk can be cut, shaped, scraped, and hollowed into a dugout canoe. But there is a problem with putting those ideas into a neat evolutionary staircase. We do not know which came first. A raft looks simpler than a canoe, but simpler does not automatically mean older. Different environments offered different materials. A group living beside a reed-filled marsh faced a different engineering problem from people surrounded by enormous trees. Early humans may have developed several kinds of watercraft independently, improved them, abandoned some designs, and reinvented others over thousands of years. So, the first boat was probably not one brilliant invention. It was a collection of solutions. First, find something that floats. Then make it stable enough to carry a human. Then add enough buoyancy for food, tools, or another person. Finally, and this is where things become surprisingly difficult, make it go somewhere other than wherever the current feels like taking you. That last step changes everything. Because something that floats can keep you out of the water. Something you can control can take you across it. And archaeology suggests humans learned that difference astonishingly early. Here is where the human body becomes part of the engineering problem. A log floats beautifully when nobody is sitting on it. Add one adult human, however, and things become less elegant. Your weight pushes it deeper into the water. Move too far to one side and it rolls. Try to stand up and you have invented swimming. So early boat building was not just about discovering buoyancy. Humans had watched branches, logs, and vegetation float for as long as humans had watched rivers. The difficult part was making that buoyancy useful. One solution is width. Lash several logs or bundles of reeds together, and you create a broader platform that resists rolling. Another is shape. Hollow a large trunk, and you remove weight while leaving a shell capable of carrying people and cargo. Then, add a pole or paddle, and you gain something even more valuable, control. And control changes the calculation. A person wading across a river is limited by depth, current, cold, and whatever unpleasant animal happens to live there. A floating craft moves the body out of the water and lets it carry more than muscles alone could manage. Food, stone, firewood, children, maybe several hunters if the craft becomes large enough. But every improvement creates another problem. Wider can mean heavier, lighter can mean less stable. A long dugout may hold its direction well but be harder to turn. A crude raft might stay upright in calm water and become miserable the moment waves arrive. There was no instruction manual. Just bodies, materials, water, and repeated experiments. And somewhere in that process, humans stopped asking, "Will this float?" They started asking, "Can we make it go there?" And this is where the neat story starts falling apart. If you want a physical prehistoric boat you can actually point to, the Pesse canoe is a wonderful candidate. Found in the Netherlands, it was made sometime around 8,250 to 7,550 BCE. It is nearly 3 meters long, carved from a single piece of wood, and unmistakably looks like the kind of solution we just described. Take a trunk. Remove material. Create space. Get in. Hope your balance is better than your confidence. It is tempting to call this the beginning. It almost certainly is not. By the time someone made the Pesse canoe, humans had already reached places requiring water crossings thousands and in some cases tens of thousands of years earlier. More than 50,000 years ago, modern humans were already reaching Sahul, the ancient landmass that joined Australia, New Guinea, and Tasmania when sea levels were lower. Even with more land exposed than today, getting there from Southeast Asia still required crossing stretches of open water between islands. No 10,000-year-old Dutch canoe can explain that timeline. The real problem is preservation. Stone tools can sit underground for tens of thousands of years and still ruin an archaeologist's afternoon in the best possible way. A wooden raft is less cooperative. Wood decays. Bark decays. Plant fiber rope decays. Reeds decay. Unless conditions are unusually favorable, an entire technology can disappear while the stone tools used to create it remain. So, archaeology has a strange blind spot. The earliest watercraft may have been enormously important and almost completely invisible, which means the question changes. Instead of asking, where is the first boat? We have to ask, what evidence would a vanished boat leave behind? Now here's the part nobody expected. One of the best clues to prehistoric boats is a shiny black rock. Obsidian is volcanic glass. It fractures into extremely sharp edges, which made it valuable for cutting tools. More importantly for archaeologists, obsidian from different volcanic sources can often be chemically matched to the place where it formed. That turns a stone tool into something like a geological address label. And in Paleolithic Japan, some of those labels point offshore. Obsidian, originating from Kozushima, an island south of central Honshu, appears at archaeological sites used by humans during the early Upper Paleolithic, around 38,000 years ago. The important detail is simple. Kozushima was an island. You cannot hunt an obsidian nodule until it swims to shore. Someone had to reach the source, obtain the stone, and bring it back across water, or take part in a chain of movement that ultimately accomplished the same thing. Either way, the rock crossed a marine barrier because humans made that possible. Notice what archaeologists do not find beside it. No 38,000-year-old canoe. No neat bundle of reeds. No paddle labeled, property of Paleolithic ferry service. The organic technology vanished. The cargo survived. And that makes obsidian a beautiful piece of detective evidence. It does not tell us exactly what the watercraft looked like. A chemical signature cannot distinguish a dugout canoe from a raft. It cannot tell us how many people were aboard, what they used as paddles, or precisely how any particular voyage was organized. But it reveals something much harder to dismiss. People were moving valuable material across a marine barrier. And to do that repeatedly, a floating object is not enough. You need enough buoyancy for people and cargo. You need stability when weight shifts. You need propulsion or steering. You need some way to launch, land, and control the craft. And if several people are aboard, you need them working together rather than improvising independently while surrounded by water. The boat itself disappeared. But a piece of volcanic glass survived to tell us what that missing technology could accomplish. Eventually, archaeology gives us something much more satisfying than a vanished boat. It gives us an actual one. The Pesse canoe is almost 3 meters long and only about 44 centimeters wide. It was made during the Mesolithic, roughly between 8,250 and 7,550 BCE, from a single piece of wood. There are no planks, no nails, no metal fittings, no clever joints, just a tree that stopped being a tree. And that tells us something important about dugout technology. First, you need the right trunk, large enough to carry someone, straight enough to shape, solid enough that removing the center does not leave you with prehistoric firewood. Then comes the expensive part, labor. With stone woodworking tools, people could cut into the trunk, chop away material, scrape surfaces, and gradually create an interior cavity. This was patient work using tools that had to be maintained and resharpened, while the builder constantly judged the material beneath them. Because hollowing a log is not simply digging a giant wooden bathtub. Remove too little, and the craft remains unnecessarily heavy. Remove too much, and the walls become weak enough to split. The bottom has to support weight, the sides have to remain high enough to keep water out. And the finished hull still has to be manageable enough to launch, paddle, and control. The Pesse canoe does not tell us exactly how the first boat was made. It comes far too late for that. But it shows that by the Mesolithic, humans could deliberately transform a large piece of timber into a working watercraft by manipulating its weight, capacity, shape, and behavior in water. That is a major technological achievement. And yet it creates another problem. If humans had already been crossing water tens of thousands of years earlier, was the dugout really the beginning? Or was it already the sophisticated descendant of something much simpler? Before boats carried humans toward distant islands, they probably solved much smaller problems. And smaller does not mean unimportant. Imagine living beside a river that floods every season. Fish gather beyond the reeds. Useful stone lies on the opposite bank. A hunting ground is separated from camp by water deep enough to make walking inconvenient and carrying anything almost impossible. Now a watercraft starts looking less like an invention and more like infrastructure. The earliest boats were probably useful for some very ordinary jobs: crossing water, reaching resources, carrying things. A raft or small canoe could move someone across a river while keeping tools, food, or firewood out of the water. In lakes, wetlands, and sheltered coastal areas, watercraft could provide access to fish, shellfish, water birds, plants, or places difficult to reach from shore. And once a craft could carry extra weight, something important changed. Water began doing part of the carrying for you. Wood, stone, meat, nets, children, other humans. Suddenly, kilograms that had to be carried on your back could float beside you. But we should be careful not to imagine the first boat builders dramatically pointing toward the horizon and announcing that today they would discover a continent. Long-distance seafaring may have grown from much more ordinary habits. Cross one river, follow one shoreline, visit one fishing place, cross a slightly wider channel, go a little farther next time. Skill accumulates that way. You learn which wood behaves well, which current pulls sideways, how much weight makes a craft unstable, where you can land, and, just as importantly, when you should stay on shore. Eventually, a tool built to reach the other side of a river becomes capable of reaching the other side of something much larger. But that creates another mystery. Did humans invent this solution once, or did water force different groups to solve the same problem again and again? There may never have been one universal path from floating log to boat. Water gave different humans different problems. In a forest crossed by rivers, large timber might make a dugout practical. In a marsh full of reeds, bundling light plant material might make more sense. In regions with bamboo, naturally buoyant stems offered another possible solution. And a craft perfectly adequate on a calm lake might become nearly useless the moment it met strong wind, waves, or a powerful current. So instead of imagining one inventor whose brilliant design spread across the planet, it is safer to imagine repeated experimentation. Humans kept meeting water. Water kept demanding answers. And then researchers tried something slightly insane. They built prehistoric-style watercraft and actually took them into the Pacific. Researchers investigating how Homo sapiens might have reached the southern Ryukyu Islands tested several possible designs. Bamboo rafts seemed promising. Bamboo floats naturally. It does not require hollowing an enormous tree. On paper, it looks like the kind of elegant shortcut prehistoric humans might have appreciated. Then came the problem. Floating well does not necessarily mean traveling well. Experimental voyages showed that simply having buoyancy was not enough when a craft had to fight real ocean conditions. So, the researchers tested a carefully made dugout canoe. And in 2019, a crew paddled an experimental canoe from Taiwan to Yonaguni, roughly 225 kilometers, across open sea, while dealing with the powerful Kuroshio current. Think about what that changes. We are no longer asking whether a primitive-looking craft can float around a sheltered pond. We are asking whether humans using a technologically plausible prehistoric solution could control a craft across serious ocean water. Later, scientific analysis published in 2025 examined how a dugout of this kind could be made with replica Upper Paleolithic tools and how such a craft performed. That does not prove Paleolithic travelers used exactly the same canoe. It does not give us the shape of their hull, the size of their crew, or the exact route they followed. What it does demonstrate is that a prehistoric technological solution capable of a demanding crossing was possible. And elsewhere, people facing different waters may have reached different solutions. That is why the first boat may be the wrong mental picture. There may have been first boats, different materials, different waters, different experiments, all solving the same ancient problem. How do we make water stop being a wall? And once that wall becomes passable, something much bigger happens. The boat does something walking cannot. It turns people separated by water into neighbors. A serious watercraft has to be built, moved, launched, loaded, paddled, and landed. On difficult water, several paddlers have to work together rather than each conducting a private argument with the ocean. Someone has to understand the current. Someone has to remember the landing place. Someone has to recognize changing conditions before everyone else notices them from underwater. Those skills have value. A good boat builder knows which tree is worth cutting and which one will reward days of work by splitting in half. An experienced paddler understands balance and rhythm. Someone familiar with shorelines, winds, currents, landmarks, and seasonal conditions can turn dangerous water into a route the group knows how to use. And routes connect people. Once watercraft become reliable, communities separated by a channel are no longer completely separated. Food can move, stone can move, tools can move, knowledge can move. People can visit, cooperate, exchange materials, find partners, and maintain relationships across water. The boat is doing more than carrying cargo. It is carrying a social network. We should not pretend we can look at one Paleolithic crossing and reconstruct exactly who commanded the crew, who owned the craft, or whether the best paddler enjoyed prehistoric celebrity status. Archaeology rarely gives us that kind of gossip, but complex water travel rewards cooperation, learned skill, memory, and shared knowledge. And that changes what a boat is. A floating object solves a physical problem. A reliable watercraft changes how an entire group moves through the world. The shore is no longer simply where the land ends. It becomes the beginning of another route. Of course, there is a part of this story that is easy to romanticize. We imagine the first successful crossing. We rarely imagine the ones that did not work. A primitive watercraft can fail in several boring, efficient ways. A lash comes loose. A hull cracks. Weight shifts at the wrong moment. Wind pushes the craft away from shore. A current that looked manageable from land turns out to be moving much faster than expected. And once the coastline disappears behind you, the problem changes completely. Now you are not just testing a boat. You are betting that your knowledge of water is good enough to bring everyone home. That matters especially around the Ryukyu Islands, where the Kuroshio current is powerful enough to carry a poorly controlled craft far away from its intended route. Modern experimental voyages show that even a workable prehistoric-style canoe demands coordinated paddling, physical endurance, and careful judgment. For ancient crews, there was no rescue boat following behind, no satellite forecast, no radio. A failed experiment could simply disappear. That does not mean early seafaring was reckless. Quite the opposite. Repeated success would reward caution, local knowledge, teamwork, and one of the most valuable technological skills humans ever developed, knowing when not to use the technology. But innovation has a hidden cost. We preserve the canoe that survived in a bog. We preserve the obsidian that reached the other side. We notice the distant islands that humans successfully settled. The failures leave almost nothing, and that silence can make ancient technology look cleaner and more inevitable than it really was. The first boats were not just clever objects. They were solutions refined in an environment where mistakes could be final. So, what is the real answer? We do not know who built the first boat. We do not know exactly when it happened. We do not know whether the earliest successful design was a raft, bundled reeds, bark, a hollowed log, or something that left no recognizable trace at all. What we know is more useful than a single inventor's story. Humans crossed significant bodies of water long before the oldest surviving boats appear in the archaeological record. That strongly implies earlier watercraft existed. And we know the problems those craft had to solve: buoyancy, stability, capacity, propulsion, control. Then, as voyages became more demanding, coordination, experience, and knowledge of the water itself. Several technological solutions were possible. Logs could be hollowed, reeds or bamboo could be bundled. Timber could be lashed into broader platforms. Different environments probably encouraged different designs, and some solutions may have appeared independently more than once. The Pesse canoe shows what sophisticated dugout technology could look like thousands of years later. Obsidian crossing marine barriers tells us earlier humans were already transporting valuable material over water. Experimental archaeology shows that apparently simple prehistoric technology could accomplish remarkably demanding journeys. But none of this gives us boat number one, because the most honest answer is that the first boat was probably not a sudden invention. It was a process. Humans turned things that floated into things that carried weight. They turned those into craft that stayed upright, then into craft that could be controlled, and eventually into technology capable of carrying people beyond the edge of the land they knew. Once that happened, water stopped being only an obstacle. Now look at what that tiny change eventually became. Today, you can cross a river on a ferry, paddle a kayak across a lake, or watch a cargo ship carry thousands of tons of goods across an ocean. None of that feels miraculous anymore. Water is just another route on a map. For most of human evolution, it was not. Go back to that prehistoric beach from the beginning. You are standing there with wood, stone tools, plant fibers, and something valuable on the other side. Now you understand what had to happen. Someone had to notice what floated. Someone had to make it stable. Someone had to discover that a broader platform could carry more weight, that removing wood from a trunk could produce a usable hull, and that a pole or paddle could turn drifting into direction. Someone had to learn the current. Someone had to judge the weather. Someone had to decide when the craft was ready. And then people had to trust it enough to climb aboard. That may be the most important step of all. The first boat did not merely carry a human across water. It changed what water meant. A river could become a road. A coastline could become a route. An island could become reachable. People separated by water could become neighbors. And eventually, an ocean could become something humans crossed, rather than simply stared at. So, the next time you see a canoe, a ferry, or a massive ship, remember where the idea probably began. Not with a shipyard, not with a blueprint, not even necessarily with a canoe, with something that floated, a stretch of water that looked impossible, and one human looking at the other side and thinking, maybe we can get there.